Unterbrochen wurden wir immer noch wegen, yeah, we were interrupted again because I lacked enough memory in my phone. I thought I could have finished it with the 2 minutes left, but it wasn't enough. So like I gave quite the complicated explanation here regarding to the shear forces distribution and stuff, but we know already that we don't actually need all of that. Like that was just the theory behind it. The only thing we need to do here is we estimate first that we got like a linear distribution of the moment, and we estimate the value we will have in the middle. It will be a half of 1 of 1 over 32 or 1/32, and that would be 1 over 64. And from that value we need to take out the value, the moment that a distributed load will cause on a simple supported beam, and that's QL squared, 1/8 of QL squared. So if I take this value out of 1 over 64, it's 1 over 64 minus 8 over 64 is minus 7 over 64. Okay, it became negative. That's the proof that we're going on the other side of the 0 line. So you don't need to think about the fact that the shear distribution here is gonna be like this. So you got the place in first, the moment needs to increase and then decrease again and still come to 0, so it needs to go to the other side. You don't need to think that way. You got the value here, you got the value there. As soon as you got values of the moment between 2 points, let's say this M1 and this M2, we can first estimate that it's a linear distribution between those 2 points, and that's going to be the case if you don't have any load between those points. And yeah, if you got a distributed load, you can just, from that estimation, from that linear interpolation, you can just calculate the middle value, and from that middle value you remove the QL squared 8. I mean, you remove it if the load is going downward, and you add it if the load is going upward. So if the load is going downward, you just remove that value. It could be like this, or it could be bigger, so it's gonna change signs. It depends on how big the distributed load is. It could be this distribution of the moment, or it could be just staying up there. Okay, for a distributed load that's directed downwards, and if it's going upward, then you just add the eighth QL squared in the other direction. So let's control those values